All right, everybody, welcome to more heat transfer through solids. Oh, guess I gotta get that so adjusted a bit. Guys, I have my temperature thermometer set again. I've got two thermometers this time, temperature 1, temperature 2. They're about the same temperature. You can see I haven't started collecting any data yet. And here is what they are attached to. So these are these two blocks that if you've got a good memory, you may remember from when we did room temperature. They are the non-metal block, which is going to go here, and then there's the metal block right here. And what I'm going to do is I am going to fill these containers up with very hot water, and then I'm going to put these on top of them, and the sensor is on the top. Now, everybody knows that if you have a hot liquid, it cools off after a pretty short time, and that's because hot's going to cold. Your hot in your liquid is going into the room to try and heat it up, and it does a little bit until they become the same temperature. So we're going to see some more heat movement on this, and this is just another example of a heat movement through solids. Now, I'm not going to show this, so I'll explain it, what's going on. So I'm going to put it back over here on what our temperatures are doing. And I'm going to go ahead and hit collect, and we'll see our two thermometers come out. The red one is the non-metal, and the blue one is the metal. And I'm going to go ahead and pour our hot water into our two containers. Try and get the same amount in each one. And I'll go ahead and I'm putting the tops on them now. So now both of them are covered with the blocks. One is the metal block, one is the non-metal block. They're both solids, so any heating up that will happen is going to happen via conduction, because that's how hot goes to cold through solids. And we can already start seeing that the blue line, which is the one that's over the solid, or excuse me, over the metal, it's the thermometer that's connected to the metal, is getting a lot warmer than that one that is on the non-metal. It's not even close right now. So you can also see the red line is going up a little bit. Hot is going to cold through the non-metal. It's certainly not doing it as efficiently it is through the metal. That metal is just letting the heat fly through it to the thermometer just like nobody's business. And that non-metal one seems a lot more reluctant to transfer that heat, although it is transferring some heat. And again, we continue to see conduction through both these solids. What we're not seeing by any means is an equal amount of conduction. So I'm going to go ahead and pull off this. You can see both of those thermometers are heating up. And we'll go right here. And again, guys, this is just an example of another part of conduction. Conduction is how heat travels through solids. Both of these conducted heats, but because some things like metals can conduct heat way better than non-metals, we say these are a conductor, which means it's like a heat highway. These are insulators. It's not a heat stop sign. They don't stop heat from going through, but they're like a school zone for heat. It has to go much, much slower. And metals tend to make very good conductors. Non-metals tend to make better insulators. Some of you guys probably have pots and pans at home that have plastic handles. And the reason you have those is so you don't burn your hand, because the heat from the handle can't go through that plastic very easy. Now, metals aren't all the same. Here is something we did earlier when we did hot goes to cold. This is aluminum. And aluminum tends to be a very, very good conductor of heat, which is why when we had the hot on one side and cold on the other, that's why the heat moved through this so fast, because it was conducting the hot over here to the cold on this side because that bar moves it really efficiently. And that's exactly what we're seeing here. One final look at our graph, which is still going. Again, you can see both of our solids are conducting temperature, but the blue one is way off the graph. We don't even know how high that is right now. So the metal one is conducting heat a lot more efficiently. And again, the idea, the metal we call a conductor, the non-metal we call an insulator. And an insulator is something that just slows heat way down. Okay? And that's it for this video.